Okay, so today the lesson is section 8.2, the binomial probability model. Today at the top of the page, if you would read that with me, it says students should be able to find the binomial probabilities and solve applied problems. So what is a probability model? Basically, it's a sequence of trials, each of which consists of repetition of a single experiment. The model was first studied by Jacob Bernoulli in the 1700s. Therefore, we will sometimes call this model the Bernoulli trials or Bernoulli model or binomial model. So I'll kind of throw those names out a lot. Random experiments are called Bernoulli trials if the same experiment is repeated several times. For instance, like you're going to flip a coin. There are only two possible outcomes, usually called successes and failures, on each trial. So like true, false, heads or tails, the light switch is on versus off. Number 3, the repeated trials are independent. And number 4, the probability of each outcome remains the same for each trial. So there's a list of examples there for Bernoulli trials: flipping a coin, guessing on a true-false test, testing the light bulb, either it's good or it's bad. Okay, going on to the box. The formula that we're going to use is actually, it looks quite complicated here, but actually we've done this before. The Bernoulli trial, in a Bernoulli trial, the probability of exactly k successes in n trials is given as, looking right here, see you have a combination of n choosing k. The probability of k happening is raised to the k power. The probability of it not happening is raised to the n minus k power. Now, another way that you'll see in your textbook is you'll see this left side right here. And that left side that I'm referring to is that b n comma k colon p. That's the same as a Bernoulli trial. Combination n choose k. P is raised to the k power. Q is raised to the n minus k. Now you're probably asking, what's Q? Q is a complement of whatever P is. 1 minus. Whoops. I just lost everything. I don't know what happened. Hopefully it's still going. All right. So that was strange. Some examples. So I have a coin is tossed 4 times, and the probability of tossing the head is 2/3. So in part A, what is the probability of obtaining exactly two tails? Well, I'm going to go here and say the probability of heads is equal to 2/3, and the probability of tails is equal to 1/3. Okay, this is like my P and this is my Q if you're looking at the formula. But I sit there and think about this way. Okay, I'm flipping the coin 4 times. So in front I'm going to have my combination 4 times. Twice I want to get tails. So what's the probability of getting tails? Well, that is 1/3. And I want that to happen twice, so I'm going to raise that to the second power. And then what's the probability of not getting tails? Well, that's going to be 2/3, and that's going to be raised to the second power, because I have to have a total of 4 tosses, so my exponents should add up to be 4. I can multiply that all out and get a final answer of 8/27. I'm not going to take the time on this video to work out each of the sets. So I'll just give you a final answer and you can check them later as you're working through them. Part B, what is the probability of obtaining at most 2 tails? That means I could have 0, 1, or 2 tails. So let's do 0 first. Combination of 4 choose 0. The probability of tails is 1/3. That's to the 0 power, which means 2/3 would have to be to the 3rd power. Whoops, not to the 3rd power. Oh, let me start that again. 1/3 is to the 0 power. 2/3 would then be to the 4th power, because I'm flipping it 4 times. Or let's get 1 tail. So combination 4 tails, or 4 flips, 1 tail occurring. 1/3 would be to the 1st, and then 2/3 would be to the 3rd. Or I could have combination 4 choose 2. I'm running out of room. I'm going to have to write smaller just a second. I got to erase. Or I can have combination 4 choose 2. 1/3 would be to the 2nd, and then 2/3 would be to the second, which that's what we already had in the previous answer. So in part B, when I throw that all in together, I'll get a final answer of 8/9 when I figure all those out. So part C, part C wants to know what's the probability of obtaining exactly 3 heads. So again, combination, how many times are you flipping the coin? For choosing 3. The probability of getting heads is 2/3. That's going to be to the third power. The probability of not getting heads would be 1/3, and that would be to the first power. And again, I could multiply that all out. 4 choose 3, remember that's 4. And then I just need to take 2 to the third and 3 to the third and multiply that by 1/3. I get 32/81 for my final answer. Part D. What is the probability of obtaining exactly 3 heads? Oh wow, here we go. If it is known that at least 1 head appears. Okay, that is my given. Given at least 1 head appears. Now, in that denominator, let's do that first. There's a couple ways you can do that. I'm going to do 1 minus no heads appearing. Because if it says at least 1 heads is occurring, we can just do the complement of that of 1 minus 0 heads occurring. That would be a combination 4 choose 0. Probability of heads was 1/3. That was going to be to the, oh no, probability of heads is 2/3. Let me erase. Probability of heads is 2/3. That is going to be to the 0. So then my 1/3, that would be to the 4th. Now let's talk about that one more time. The denominator is my given part. It is known at least 1 head occurs. So I did, in my denominator, 1 minus no heads occurring. That means it's going to be all tails. So I wrote this in terms of no heads occurring. So that would be 1 minus combination 4 choose 0. 2/3 would be to the 0 because that's a probability of heads occurring. And then 1/3 would be to the 4th power. Now, what was I trying to find the probability of? Exactly 3 heads. Well, I just did that one in the previous one. So if I'm just doing my setup, that would be a combination 4 choose 3. 2/3 would be to the 3rd. 1/3 is to the 1st. Okay, so let's take the time to work this one out. Since I've already got the numerator from the previous problem, 32/81 over 1 minus 4 choose 0 is 1. 2/3 to the 0 is 1. 1/3 to the 4th would be 1/81. So I get 32/81 divided by 80/81. So I get 32/80. Now if you want to reduce 32/80, that's fine by me. I would get 2/5 if I reduce it completely. Okay? There's the first page. Second page, we just have a bunch of examples that I just want to kind of go through with you. Reading number 2. In a game of chance, you play by rolling a fair die 4 times and you count the number of results, which are 6s. What is the probability that in one play of the game you obtain exactly 3 6s? So how many times am I rolling the die? Go back and look at that. Circle if you need to. 4 times. So I'm going to start with a combination of 4. How many times do I want to get 6s? 3 6s. So that would be 4 choose 3. What's the probability of getting a 6? Isn't that 1/6 on a fair die? So I'd be taking my 1/6 and I want that to occur 3 times, so I raise it to the 3rd power. The probability of not getting a 6 would be 5/6, and that's going to be raised to the 1st power because remember the exponents have to add up to the number of times that you're playing the game. In this case, rolling the fair die 4 times. Alrighty, that's number 2. Number 3, a National Football League kicker knows he can make 1/4 of his field goal attempts from more than 50 yards. So I'm going to write the probability that he makes them is 1/4. He also knows they are independent trials In a certain game, he attempts 5 field goals of more than 50 yards. What is the probability he will make at least 2 of the attempts? So if he makes them with the probability of 1/4, he's going to miss them with a probability of 3/4. He's going to make at least 2 of the 5 attempts. Okay, you can do it 2 different ways. Let's do it using 2, 3, or 4. Let's do it that way first. So if I want to make exactly 2, that would be a combination of he's going to kick it 5 times, twice he's going to make it. That would be 1/4 to the second, and then 3/4 would be to the third. Or he can make it 3 times. Combination 5, choose 3. 1/4 is going to be to the third power, and then therefore the 3/4 would be raised to the second power. Or you can have a combination of 5, choose 4. Oh, I might not have enough room. Let me squeeze it in here. Combination 5, choose 4. 1/4 is to the fourth power. 3/4 would be to the first. Or you could have combination 5, choose 5. And I'm running out of room for sure. And then I would have 1/4 would be to the fifth power, and 3/4 would be to the 0. Okay, this would be a setup only. Okay, so there's one way of doing it. Okay, and again, at the very end, let me see if I can write that a little bit better. Combination 5, choose 5, that is 1/4 to the fifth. Okay, or that's times 3/4 to the 0, which is just 1. So I'm still, give me a couple minutes here. I'm going to fix that. Okay, the other method of doing this is to do 1 minus what you don't want. So it says I want to make at least 2 of them. So basically the probability of at least 2 would be the same as 1 minus a probability of at most 1. Okay. So doing that one, I would have 1 minus, I would have either 0 or 1 miss. So I'd have a combination of 5, choose 0. Probability of missing, or no, making it, not missing it, making it. 1/4 would be to the 0, and 3/4 would be to the fifth. Now one more time, I'm going to find the probability he will make at least 2 of the 5 attempts. So the second method I'm showing you is an option. You could do 1 minus at most 1 success. So I'm going to have 0 making it, and then 1 kick making it. So 1 minus 0 successes would be combination 5, choose 0, 1/4 to the 0, 3/4 to the fifth. I'm also going to subtract making the field goal 1 time, combination of 5, choose 1, and then 1/4 is to the first, 3/4 is to the fourth. So you have a choice here. You could use the method that I wrote in black, or you can use the method that I wrote in blue ink. So either one of those, it doesn't matter. Okay, again, that would be setup only. Now, number 4, we're going to omit that one. Yay, skip that. Number 5. In an 8-question multiple choice test, each question has 4 choices, and you are told that one and only one is correct. If you guess at all 8 questions, what is the probability that you get exactly 2 right? Again, let's just do this one, setup only. Why don't you pause the video just for a couple seconds and see if you can set that one up, and just again, setup only. Okay, so hopefully you've had enough time to get that figured out. If you want to get exactly 2 correct, that would be a combination of 8, choose 2. 1/4 would be the probability of getting it correct. That would be to the second power. The probability of missing it would be 3/4, and that would be to the sixth power. So there we go. Did you get it right? Number 6. Number 6, a basketball player makes each of his shots with a probability of 0.5. If the result of his shots are independent, find the probability that he makes at least 4 shots when he takes 6. So once again, why don't you shut off the video or pause it and then take some time to do example 6, and then I'll follow up with an answer here in a second. Okay, so let's see if you agree with what I had. I have a combination of 6 choose 4, 0.5 to the 4th times 0.5 squared, plus a combination of 6 choose 5, 0.5 to the 5th, 0.5 to the 1st, plus a combination of 6 choose 6, 0.5 to the 6th. Again, I would probably just leave this one as a setup only, but I was just kind of curious if anybody thought to set it up this way. Since your 0.5 are the same for making it and missing it, did anybody think of doing combination of 6 choose 4 and then just doing 0.5 to the 6th plus combination 6 choose 5, 0.5 to the 6th plus combination 6 choose 6, 0.5 to the 6th? Did anybody think about doing that? That is an acceptable way as well. So either one, I don't really care. The second one's just kind of like simplifying your powers. All right, that's all the notes that I have for section 8.2. Thank you and have a great day.